Hello all, my name is Professor Sheetal V. Patel, Assistant Professor in AIT Engineering College. Today we will see our topic context-free grammar. It is also called CFG. CFG is used to represent the non-regular language. Earlier we have seen FA and variations of FA. But FA are used to represent the regular language. They are not supporting the representation of non-regular language. So CFG is a solution to represent these type of languages. Here in CFG, the language is represented using a set of equations or productions. Means we will derive different productions to represent the particular language that we will see by example later on. Here equations are recursive in nature and the equations has a set of variables and terminals. Here the variables are represented by capital letters and terminals are represented by small letters. In this given figure, there is an DFA and the equivalent grammar for this particular DFA. In the first DFA, X is the start state and Y is the end state, and from X to Y, there is a processing of input symbol A. The equivalent grammar for this DFA is X tends to A. The meaning of this production is X equal to A or X generates A. Number 2 is X generates multiple number of A's and X forward input symbol B to final state Y. The equivalent grammar for this DFA is X tends to AX and X tends to B. This first production generates multiple number of A's and the second production generates input symbol B. Now we will derive different strings from these productions. Start with the start symbol X, X equal to AX. I can represent this X using AX again. So I have put value of X equal to AX over here. Again I have put value of X by AX over here. And again after generating 3 A's, now I am giving the value of X equal to B over here. So this is the end of string. Because over here I have received multiple terminals instead of non-terminals. Okay. So the third DFA is X generates multiple number of A's. The equivalent grammar for this particular DFA is X tends to AX. This production generates multiple number of A's and the value of X can be null also. Means if I am not processing this self loop of A, by default the value of X will be null. So there are two productions, X tends to AX and X tends to null. Now I am deriving the strings from this particular production. X equal to AX, again I am giving the value of X is equal to AX over here. Again instead of X I put the value AX and instead of this X I put the value null over here. So at the end of processing different productions I receive the string AAA. So the meaning of this particular grammar is this generates multiple number of A's followed by null value. Now I can generate non-regular language using the context-free grammar. So this is one example of non-regular grammar. Earlier in the pumping lemma topic we have seen the example of this particular language and we have proved that this particular language is non-regular using the pumping lemma theorem. So we will represent it using a set of productions. So first of all I will analyze this particular language and I will write a raised to n minus 1 into a instead of a raised to n and b raised to n minus 1 into b instead of b raised to n. So this is equivalent to a raised to n and this is equivalent to b raised to n. Now instead of this a raised to n minus 1 and b raised to n minus 1 I am giving the value x, and instead of this a and b I am again giving the value x. So now I can derive the productions for this particular language. So the production is X tends to AXB because the first letter is A. So A I have written over here. The last letter is B. So B I have written at the last. And the middle part is X. So I have written X over here. And the value of this X is recursive in nature. So again I have written X tends to AB over here. So instead of X I can return AXB or AB. And I can generate the different strings. So first of all, I have start with my first production x equal to axb. Instead of this x, I have written axb. Again, instead of this x, I have written axb. And again, instead of this x, I have written null value. So I have generated the string triple A triple B, that is equal to a raised to 3 b raised to 3. So by using this production, I can generate equal number of a's and equal number of b's. Now in the next topic, we will see the definition of CFG. CFG is a quadruple which consists of 4 tuples v, t, p and s, where v is a set of variables. Variables are represented by capital letters. T is a set of terminals. Terminals are always represented by small letters. P are the set of productions and S is the start symbol. We will see these 4 tuples by using one example. Over here, S is the start symbol, this S is the start symbol, and this S represents the variable. Always in our production, the first production will be the start symbol and other productions are the variables, we can say. And always the variables will be in the form of capital letters. In the right hand side, 0 and 1 are the terminals, and this S is the variable or non-terminal. Sigma also we can say it as a terminal, because instead of 0, 1, sigma, there is no any other value, but instead of S we can put 0 S1 or null value. And this whole thing is called the productions, means these two are the productions. Now derivation of string from CFG. We can derive different string from particular CFG, and the derivations are represented either in the sentential form or past tense form. We will see these two types of forms one by one in our lecture. First of all, we will see the sentential form. The sentential form are of the two types, left sentential form and right sentential form. We will see these two types of form by example. The example is given below. There are 3 types of production, S, A and B, and the values of these three productions are represented at the right hand side. Now give the leftmost and rightmost derivation of the string 1001. Means I have to generate the string 1001 from this grammar by using the leftmost derivation and by using the rightmost derivation. So first of all, I will generate the given string using the leftmost derivation. So start with the start symbol, S tends to A1B. In the leftmost derivation, always we will process from left to right. So take the leftmost character. Our leftmost character is A. So instead of A, put some values. Over here, the values of A's are 0, A and null. But in our answer, we want 1001. So by using A, we cannot generate 1. So put null instead of 1. Means we will use this production A tends to null. What are the productions that we are using? We will write at the right hand side of the productions. Now this one is generated. Now instead of B, we will put 0B, these productions, because after 1 we want 2 zeros. So 2 times I will use this same production, B tends to 0B. Okay, after 2 0 I want 1. So I will use the production B tends to 1B over here. So I have written 1B instead of this B. And now after 1001 I do not want anything. So instead of B I will put the null. Means I have used the production B tends to null over here. So I have received the target string 1001 using the leftmost derivation. The second one is the rightmost derivation. In the rightmost derivation, always we will process from right to left. In our production, the rightmost character is B. So instead of B, put some values. Over here, we want 1001. 1 is already there, and now we want 001. So instead of B, put the B tends to 0B. Again, instead of B, put 0B. And again, instead of B, put 1B. After putting 1B, 1001, which I will get So now I do not want anything. So replace B by null value and also replace A by null value. So in the rightmost derivation, I will proceed from right to left. So these are the two ways through which I can generate the. Now the next topic is parse tree form. In the parse tree form method, we will derive particular tree from specific productions. Over here, we will generate one root node, and from the root node we will derive different child nodes. Over here, a set of equations or derivations are applied to generate a word can be represented using a tree, and such a tree is called parse tree. We will see this parse tree form method by using the example. In the examples, we have given the three productions S, A and B, and the values of S, A and B are written over here at the right hand side. And give parse tree for leftmost and rightmost derivation for the string 1001. Now we will see the parse tree for leftmost derivation of 1001. So always we will start with the start symbol S. So S equal to A1B. Okay. Now we want 1001. So 1 is already there, and before 1 we do not want anything. So instead of A, we will put null value over here. Means we will use this production A tends to null. Okay. Now after 1 there is a B, which is also non-terminal, and the values of B's are represented in these productions. So instead of B, I will put 0B. Again instead of B, I will put 0B. And after generating two zeros, now I want 1 in my string. So instead of B, I will use this production B tends to 1B. So I written over here 1B, and now after generating 1001, I do not want anything. So instead of B, I will put the null value. Means I have used this production B tends to null over here. Okay, after generating this parse tree, now I will process the whole parse tree from left to right, because this is the leftmost derivation. So in the leftmost derivation, always we will process our tree from left to right. So process the tree sigma null 0 0 1 null. So at the end, I have received the string 1001, which is my answer. Now the next method is parse tree for rightmost derivation. In the rightmost derivation, always we will use the rightmost character. So over here we have start with the start symbol S. The value of S is A1B. Now the rightmost character is B. So replace B by some values. 1 is already there. So now I want 00. So I will use the production B tends to 0B over here. Again I will use B tends to 0B over here. And after 20 I want 1. So I will use the production B tends to 1B. And then after I do not want anything. So I will use the production B tends to null over here. So this is the end of my parse tree. And after generating the parse tree, I will process the whole tree from right to left, because it is the rightmost derivation. So process the tree from right to left. Sigma 1 0 0 1 null. So at the end I will receive the string 1001, which is my answer. So in this way I can also derive my string by using the parse tree form, and we can use the rightmost derivation and leftmost derivation to generate the specific string. Now in the next lecture we will see the union rule for the grammar. Thank you.